In 12.4, we are continuing with our practice with different transformations. But first, for the warm-up, I want you to, just by memory, see how much of the parent functions you remember the shape of. So go ahead and sketch the general shape of each parent function. So like for the linear, it's just a straight line, y equals x, or f of x equals x. Just a straight line like this. The x squared is a parabola, so it kind of looks like this. So basic general shape. So go ahead and pause the video, do that, and then we can check. The logarithmic has a, I guess we could put arrows on these. The logarithmic has a vertical asymptote and then curves up to the right. The exponential has a horizontal asymptote, and then that's a growth. Okay, cubic looks kind of like this with that at the origin, the middle at the origin. Cube root, kind of the same idea, but it's sideways. These are inverses of each other, the cubic and the cube root. Absolute value is the v. That's normally at the origin. The reciprocal function is in two pieces. Normally looks like this, and then the square root normally starts at the origin and then goes off to the right. So important that we still are able to look at a graph and recognize what the parent function is just based off of the shape. Whether it's been stretched or reflected or anything, we have to know which one it's connected to, so then we can write equations for it. So the more transformations we have all of the ones that we talked about last unit, but we're going to add some more. So we just have the stretch and compression we're going to add today. So we have the vertical stretch by k, and then this happens by taking our function, whatever it is, and just multiplying it by k times f of x. And that's it. And so vertical stretch by k means that k is going to be greater than 1. Any number that's greater than 1, if I times by a number greater than 1, it's going to make it bigger or taller, since this is a vertical stretch. But it's actually the same rule if it's a vertical compression or a shrink. It's called a lot of different things, but vertical compression by q. And this time it's the same rule over on the right side, except q is going to be less than 1. I guess the absolute value of both of these. Absolute value of k is greater than 1. Absolute value of q is less than 1. So f of x equals q times f of x. But it'll just look like a fraction times your function, something like that. So that's how you tell the difference between vertical and stretch and compression, by the number that you're multiplying by. Bigger than 1, it's a stretch. Less than 1, it's a compression. Okay, and then horizontal. Horizontal, same idea, stretch and compression. Stretch by r. So horizontal means we're stretching it right and left. So this means we're changing the x values. So the change is going to happen on the inside with the x, wherever the x is. And insiders are liars. So this time, instead of multiplying, we're going to be dividing by r. And again, it's a stretch. So that means the absolute value of r is going to be greater than 1. And last but not least, we have our horizontal compression by t, where absolute value of t, since it's a compression, is going to be less than 1. But it's the same rule. F of x becomes, I guess these should all be arrows, because they're not equal to each other. They just become. F of x becomes f of x divided by t. Insiders are liars. So let's see if we can use these to write our new function. So vertically stretch the logarithmic parent function. So you have all of the equations up top. So logarithmic parent function, the one we're using anyway, is log base 2 of x. So we're going to do vertical stretch by 4. So using our table up here, vertical stretch by 4 means we're just going to times our function by 4. So this is going to become 4 times log base 2 of x. But then we also are going to translate 1 unit right. So if you go back up, look at 1 unit right. That's going to be minus x minus d, where the x is. So you have to go to the x. Remember, anytime you're changing something with the x, you put the x in parentheses, and that's where you make the change. So if I'm going to go 1 right, I have to do minus right on the inside of the parentheses. And there we go, and we rename it. It does not get the same name. That's kind of a big deal. It does not get the same name. So, yeah, because it's a new function. We've transformed it. So there we go. We have a vertical stretch and a translate 1 right. Okay, and for all of these, pause the video, try it out first, and then check your answer. The linear parent function is just x. We're going to reflect across the y-axis, so you go to where x is. Oh, it's not going to be f of x anymore. You go to where x is, you make x negative. And since x is the only thing, you can put it in parentheses or you don't have to. But then after that, we're going to do a horizontal stretch by 7. So this is where you go where the x is. So let's parentheses this time. And inside the parentheses, horizontal stretch by 7, insiders are liars. So we are going to do x divided by 7 inside those parentheses. And that's our new function. So we give it a new name, g of x. Example 3, translate absolute value parent function. So we start with the absolute value of x. So translate it 4 units left. So left meaning we're looking inside, and the absolute values kind of act like parentheses. So we just need to make sure 4 units left, that plus 4 goes inside those absolute values. And then a vertically compressed by a factor of 1/4. So vertical compression, we're just multiplying the front of the equation. So 1/4 times our function. And there we go. There's our new one. Okay, example 4. Exponential parent function. So we're starting with, I'll start over here with 2 to the x. This is one of the exponential parent functions. I reflect across the x-axis. So the first change is this becomes negative. You just put a negative on the front for reflect across the x-axis. 4 units right, so you go to where the x is, which is up here, and it becomes 4 units right minus 4 with where the x is. And then, oh man, there's more. And then horizontally compressed by a factor of 2/3. Okay, this can be tricky. So we're going to where the x is, which is right there. I'm going to rewrite this so I have a little bit more space. So this becomes 2, and then we already have some parentheses up here. But then x gets divided by 2/3, and then we still have our minus 4. And that's kind of in its own set of parentheses. However, we want to simplify this a little bit. So our final answer, g of x, is going to equal -2 to the power of, and we can put this in parentheses or not because it's in the exponent. Dividing by a fraction is the same as timesing by its reciprocal. So if I'm dividing by 3/2 or 2/3, that's the same as multiplying by 3/2. So I'm just going to flip that fraction upside down, times x instead of x divided by that, and minus 4. And that is going to be our changed fraction, or changed equation. Okay, here you just have to describe the transformation. So our original function is x cubed. So that x cubed is the part that stays the same. So we need to figure out, okay, what is this 4/5 doing and what is the plus 7 doing? So in general, going left to right to identify, because sometimes the order does matter, left to right usually puts it in a good place. So usually gets you in the right order. So 4/5 we'll do that first, and we're just timesing x over 3 by 4/5. So that's going to be a vertical. It's not where the x is, not in parentheses with the x. So this is going to be a vertical, and 4/5 is less than 1. So this is going to be a vertical compression by 4/5. And make sure you always include that number. Okay, and then we got the 4/5, and then the plus 7 looks like a translation. Just a plus 7 at the end. It's not with the x in parentheses. So that's going to be a translation up 7. So don't forget to use that table.